Hello guys, today I'll be talking to you about the inverse of trig functions. So before talking about the actual inverse of trig functions, I'll tell you what the six main trig functions are. So these will be sine, cosine, tangent, cosecant, secant, and cotangent. And what these are used for is, given an angle of a triangle, we should be able to find one of the sides of the triangle. So for example, say they give us what is sine of pi over 4. Pi over 4 is simply an angle, except it is in radian form instead of degrees. To convert it to degrees, we should know that pi is equal to 180, and we just divide that by 4, and the same thing is sine of 45 degrees. Okay. To figure this out, I'll be solving this through the use of a unit circle. Now, the thing that is good about the unit circle is that every single point is exactly 1 unit away from the center. So here I drew where the line will be for pi over 4, and I drew the triangle that comes from it. And this is basically a bigger version of this triangle, 45 degrees and 90 degrees, because this is a right triangle which has a 45-degree angle, which was given to us, and so therefore the other side must also be 45 degrees. Because this is a 45, 90-degree triangle, we should know that 2 of the sides will be the same, and that the hypotenuse is 1 because it is part of the unit circle. So, a lot of us remember from our days of pre-calc that sine of pi over 4 is equal to the square root of 2 over 2. To actually solve for it, however, we have to use the Pythagorean theorem. If you guys remember what that is, it is a squared plus b squared is equal to c squared. In this particular case, a will be this side, which is the side that we're actually looking for. B will be this side, and c, which is the hypotenuse, will be this side. Okay, so here it is, x squared plus x squared is equal to 1 squared. I simplify this to 2x squared is equal to 1. I divided it by both sides by 2, so x squared is equal to 1/2. Then I took the square root of both sides, so x is equal to 1 over the square root of 2. Now, to get rid of the square root sign at the bottom, I multiplied both sides by the square root of 2, which would give me the answer of the square root of 2 over 2, which is the value that a lot of us still remember from our days of pre-calc, and that we had to memorize from the unit circle. Okay, now actually going on to the inverse of these trig functions that are given. So the inverses are written in 2 different ways. The first is by writing the prefix arc, and the other is by putting the exponent of -1. So both of these are said to be arc sine. They are said the same way, but they're just 2 different ways of writing it, both which are equally valid. So each one will be written will still be written in either form. So arc sines or arc sine, arc cosine, arc cosine, arc tangent, and so on and so forth. Now, since we found out with the use of an angle, we found out the length of the side. The inverse can do just the opposite. With the length of a side, we can find the angle that is necessary for it. So let us ask instead, what is the arc sine of the square root of 2 over 2? And that is basically asking, given that the length is the square root of 2 over 2 given that the length of a triangle side is equal to the square root of 2 over 2, what is the angle necessary? And this is basically the opposite of the question that I just asked you before, what is sine of pi over 4? And you guys should probably realize that this is pi over 4. However, there arises a problem that there can be multiple answers because sine and all of the trigonometric functions are actually not 1-to-1. Rather, they have multiple different answers because they are periodical. And so another answer instead of pi over 4 could be pi over 4 plus 2 pi, which is simply 360 degrees away from it, which is the same exact point. Or another way of saying it is pi over 4 or plus 4 pi, which is basically the same side that's given. And so to prevent this, what mathematicians have done is they have restricted the domain of the trigonometric functions. And by doing so, they have made each function one-to-one, because a function cannot have an inverse unless it is one-to-one, or at least not an inverse that is defined. Because right now we're having multiple different answers for one single question. So what mathematicians have done to make it one-to-one is they have selected a specific period for each function, and by using this restricted domain, an inverse can be defined. So here are the restrictions that I put. These are all for the domain. So sine of x, the restrictions are negative pi over 2 to pi over 2. For cosine, it's 0 to pi. For tangent, it's negative pi over 2 to pi over 2. For cotangent, it's from 0 to pi. From secant, it's 0 to pi over 2, connecting with pi over 2 to pi, and so on and so forth. So each of these have a restriction that make an inverse defined. And so this is what inverse trig functions do, and this is why we have restrictions on them, and this is why they only work in certain cases, because we want them to be one-to-one so that the functions can actually have a defined inverse. Alright, bye guys.